Welcome to our today's lecture. So, from today we will start on a new module, and this module will be about product life cycle design. As we spoke about while we were trying to understand what sustainability is, product life cycle design approach is a product innovation level approach. It comes in the eco design category, where we try to understand what are the different life cycle impacts of a product on the environment and try to design accordingly. So, in this first series of lectures in this module, first we will try to understand today the concept of product life cycle. Then we will talk about life cycle assessment and how do we design for product life cycle. So, what is product life cycle, or in short it is called as PLC. So, in different domains there are different definitions of product life cycle. If you read literature from marketing, product life cycle is defined in a very different terms. So, let us start with product life cycle definition, which is applicable to the context that we are talking about. So, what this means is talking about all the stages or phases of product life cycle. So, for any product, say a chair, a table, a mobile phone, any product, it starts with raw material extraction. So, if my chair is supposed to be made of plastic, my raw material extraction might mean extraction of petroleum, because plastics comes from petroleum. Say if I make my table out of some components which are made from wood, whereas other components are made up of glass and metal. So, then I will have material harvesting. So, the wood is harvested. For the metal parts, it will be extraction of those particular metals. So, if it is made up of stainless steel, we will extract iron ore to make the stainless steel. For the plastic components into it, again we will extract petroleum from the earth. Then we need to transport all these raw materials to the manufacturing site. So, next in the product life cycle comes material processing. So, what do we mean by material processing? There is a difference between material processing and manufacturing, which will be the next phase. In material processing, so from petroleum you will convert it into the kind of plastic that you want to use in your chair, or you will convert the wood into the kind of wood product that you want to use in your table. So, in material processing, we try to process the raw materials into certain forms which will be then used for production or manufacturing of our product. So, it also involves all the transportation up to the production site. So, the transportation of the raw material to the material processing site is involved in the previous step. In the material processing, what I am talking about, the transportation to the production site, which is my next site. So, in product manufacturing or assembly, so I will manufacture the product. What is the difference between manufacturing and assembly is, so say my table consists of 5 different components. So, I will first manufacture each of those components and then I will join them together, and that is called as the assembly process. Or say for example, a car. First, each and every component will be manufactured either in the factory itself or it will be bought out from another factory, and there will be a particular assembly line where all those components will be assembled together to make a car. So, in this stage of the product life, we include product manufacturing and assembly. Packaging, we need to package the product so that it does not get damaged when I am transporting it. Then transportation to the final distribution, which might mean transportation from the factory to the wholesaler's place to the distributor's place. Distributor is someone who is the place from which me as a consumer will go and buy, and from the shop from which the consumer will buy up to the consumer's house. So, this transportation to final distribution means all these transportations from the factory at which it has been assembled up to the house of the final consumer. Next comes the use and maintenance phase. So when we are trying to use that product, so energy and emissions during normal product life, required maintenance and product reuse. So say for example, I might buy a refrigerator. After a couple of years, I might decide to give that refrigerator to someone else. So then the same refrigerator is still in the consumer market and it is being reused. So this reuse means that kind of a reuse, and not like changing the product form into another form and reusing it. The last phase is the end of life. End of life contains many different processes. So at end of life, multiple things can happen to my product. Either it can be recycled if it has been designed for recycling, or if recycling is possible, it can end up in the landfills. It can also become some kind of a waste, which in terms of solid waste, liquid waste, or sometimes some kind of gas emission in case if it is burnt. So these are the various phases or stages of a product life cycle. So in order to have a product life cycle based design approach for sustainability, what we have to consider is what are the environmental impacts of each and every stage of this life cycle on the environment. So how do we do that? Before getting into it, so end of life can mean that it goes into a reuse, which was already accounted for in the use and maintenance phase. So my refrigerator, rather than going to a landfill or something, it's reused by somebody else. It can also go for remanufacturing. So say my air conditioner has been built in a manner that the outer casing can still remain the same. Certain internal components can be changed in that, and then again it can be reused. So in that particular case, I send it back to the manufacturer for a remanufacturing, and then again it is ready for the use and maintenance phase. Another option at the end of life is recycling. What it implies that it has to go back to the material processing unit, where my product will be broken apart into the components, and then it will be reprocessed to give you the original material. These materials can be used in the same industry from which it came, or it can be used in any other industry. Or the fourth option is discard it away. Even in discarding it away, we can either put it into a landfill, which is real waste of precious resources, but there are also end of life processes like incineration, and after you incinerate the product, you reduce the volume of the waste. So the small amount of waste can be landfill. During the incineration process, you can extract the energy, and that energy can be used for any of these material extraction, material processing, product manufacturing, or any other purpose for which you require energy. So that is called as energy recovery process. So now coming to what is life cycle assessment. So in this particular product life cycle, which consists of raw material extraction, material processing, product manufacturing and assembly, use and maintenance, and end of life, when we try to find out what are the energy and material inputs at each and every stages, and what are the emissions into the air, and what are the emissions to water and soil as a result of each and every stage of the product life cycle, what we are doing is life cycle assessment. So you can see, why do I have energy and raw material only at the beginning of it? Because it is assumed that this energy and raw material, so it will comprise of all the energy and raw materials that I am talking about at this particular phase, and then new material entrance does not happen. So when we go into the example on how to do it, we will see new material only flows in this particular direction, but there might be also some processes. Say for example, the end of life generates some byproducts. These byproducts, which are also materials, can go into any of these other cycles. I will not only require energy over here, but I also require energy over here. So as a result, these energy and material has been put at one particular end, but it does not mean that the entry is only to raw material. The energy and material is into the whole system, and all the emissions to air and emissions to water and soil as a result of that. Now, life cycle assessment, or as it is called as an LCA, LCA is a method to calculate the environmental burden of a product or service. So, the purpose of LCA is to identify burden of a product or service. So, because the aim is so, that's why we are trying to identify. How do we identify the burden of a product or service on the environment? By trying to identify how much energy it is consuming, how much material is it depleting, and how much emissions it is causing to the air and emissions it is causing to water and soil. So, these calculations are based on a systems approach. Now, this is an whole system of the chain of production and consumption. It analyzes the input and the output of the total system. So, the inputs are materials which are natural resources and can also be recycled materials, the energy and the transportation. The output in these cases are the products and or services, emissions to air, water and soil, any kind of byproduct, recycling products, feedstock for electrical power plants. So, when I burn it, I am doing energy recovery, which can be used as a feedstock for electrical power plants, which then supplies power to other processes. The output is also waste for landfill, waste for incineration or other types of waste treatment. So, if we try to see, this is the complete picture. So, on the input side is my energy, materials and transport. The transport can be actually classified in terms of the energy and emissions, again further brought it down. Then I have my output, which keeps on either cycling in this. So, when I say recycling, it can keep on cycling in this, or it might also end into the end of life. So, what is life cycle design approach? So, there are two approaches in this case. The first approach says that from designing a product to design the product life cycle stages, that is all the activities needed to produce the material and then the product, to distribute it, to use it and finally to dispose it. So, consider a holistic approach. So, in that particular case, when we consider a holistic approach, what we can find out is in which of these stages my emissions to air or emissions to water and soil is the highest, or in which of these stages my energy consumption is very high, or in which of these stages my material consumption is very high and it can be reduced. So, this particular approach, where we shift from designing a product to designing the product life cycle stages, can be helpful in reducing the environmental impact. Another approach, which is a better approach than this, is called as the functional approach. What we try, so in the first approach, the life cycle approach, what we are trying to talk about, designing a product to designing the product life cycle stages. So, I take a washing machine. So, from design a washing machine with certain kind of impact on the environment, I try to design a more environmentally friendly washing machine than the previous one. But in the functional approach, we, rather than starting from the product embodiment, so the first example of the washing machine was where I am trying to develop a better washing machine, was an example of product embodiment level improvement. But why in functional approach we start from the function rather than the physical embodiment of the product itself. What it might mean is, say in washing machine, I need to churn my clothes along with detergent and water to get the dirt out of the cloth. My basic functionality over here is, how do I remove the dirt from the cloth? Then I can start thinking from how that functionality can be achieved in a different manner, rather than churning the clothes and the water in the washing machine. So, if I can come up with a solution which is functionally less environmentally damaging than churning clothes in a washing machine, I call this as a functional approach for life cycle design. So, it has been understood that environmental assessment and therefore also design must have its reference the function provided by a given product rather than the product embodiment. Then you can bring in much greater reduction in environmental impact. The design must thus consider the product less than the service or result procured by the product. So, LCA is a method. So, if I ask you, I can transport fruits and vegetables using my first option, which is paper crates. These are recycled paper. This is my other option, in which I can use plastic crates. Which one is a more environmentally friendly solution? You might assume that because this is recycled paper, this is more environmentally friendly rather than the second case, which is using some kind of plastic. It is only when we do an life cycle assessment we can actually say which one is better. Why so? So, it has been observed that these plastic crates, they can be used for about 6 to 7 times. After that, those crates are no longer structurally strong enough to carry the fruits and vegetables over large distances. So, they will have to be discarded. The paper crates, on the other hand, they can be used only once. After that, they have to be discarded. So, now imagine a truck which is bringing fruits and vegetables from place A to a market in place B, comes with a truckload full of fruits and vegetables in plastic crate. It has to go back to place A where my fields are located with empty crates, whereas my paper crates, because now the paper crates are to be discarded, so my truck goes away empty handed. Another situation, a paper crate is lighter weight as compared to a plastic crate. So, now a plastic crate, because it is heavier, it will consume more fuel in transportation as compared to the paper crate, considering the weight of fruits and vegetables remains the same. So, now when we add on to all these different calculations, depending on the distance between point A to point B, the place from which I am sourcing my recycled paper, the place from which I am sourcing my plastic crates, I can have different results. It has been found out that in some context the paper comes out to be more environmentally friendly, whereas in many other cases the plastic crate comes to be more environmentally friendly. I missed on to another thing which I had discussed in the previous class. Paper is not infinitely recyclable. So, this particular paper crate, it is almost at the end of its life cycle. So, it cannot be recycled anymore. So, it has to go to a landfill for final resting. The ink used on this paper crates might be very environmentally damaging. So, how do I find out the environmental impact of each of these products? The only answer to it is life cycle assessment, and it has been through many of these examples, it has already been seen that it is very contextual. Sometimes the paper comes more sustainable and other times the plastic. Again, this is an example that we were talking about in our previous lectures, which is more environmentally sustainable. Having water which is to be drunk from PET water bottles or glass bottles, or having a dispenser with disposable cups or washable, rewashable, reusable cups. So, if you consider the PET bottles, the weight of the empty container is extremely low, whereas if you compare it versus the glass bottle, the dead weight of the bottle is very high. Just take two of these kind of bottles, try to compare the weight. The difference in weight is very high. As a result, the fuel expenditure in water filled in plastic bottle versus that filled in glass bottle, the glass bottle fuel expenditure is very high. But my glass can be reused. My plastic bottle, it cannot be reused, but it can be recycled and put into other functionalities. I need to spend energy in cleaning my glass bottles so that they can be refilled again. Say my glass bottle gets damaged, the amount of glass is recyclable. You can again put it through the heat treatment cycle and you can again get back glass, but that consumes a lot of energy. So, when we do all these calculations, then our initial very quick intuition based answers that glass bottle is better, or the glass made of glass, or the paper cup, or the cooler as we were discussing in our first lecture is better, those intuitive answers might come out to be completely wrong. So life cycle assessment gives us all those tools in which I can calculate the environmental impact in terms of materials, energy, emissions to air and emissions to water for each of these products along its entire life cycle, that is from raw material extraction to material processing to production to distribution to use and maintenance to end of life, and come to a conclusion that in a given context the results that you get under a given context is never same in another context, it varies. So, in a given context this particular product is more environmental friendly. So, there are many companies who use the life cycle assessment method very rigorously in the products that they try to develop. So, P&G, GE, Huawei, DuPont, Goodyear, HP, these are just very few big names to start with. You can read this particular paper which I have mentioned on this slide. It's a paper which talks about life cycle assessment, measured environmental improvements in Pampers, the diapers. So, it compares the diapers which used to be made in 2007 versus those which were made in 2010. So, the company had done design and material changes in order to improve the performance. So, what the researchers tried to study by using a life cycle assessment method is whether it also brought in environmental improvements and also or not. So, when you go through the paper, you can see there are different parameters on which environmental improvements could be brought in. So, this shows that businesses can use LCA to decrease their footprint, create opportunities and make value chains more sustainable. Remember that what we are trying to talk about is reducing the impacts without changing behavior of people. So, I am not doing anything in which people will be motivated towards more environmental friendly consumption. So, life cycle assessment does not ensure that. Life cycle assessment ensures that you know the impact and you as a designer can redesign the life cycle processes or stages so that you can reduce the environmental impact. So, before we get into how to do life cycle assessment, we will start with some key terminologies that are essential to understand this concept. So, the first one is the concept of eco-cost. So, why are we doing this life cycle assessment? Of course, we come to know about the environmental impact. Now, how do I translate that in terms of money? That is covered in the concept of eco-cost, and I will come to the fact like why it is necessary to convert it into in terms of money. So, eco-costs are a measure to express the amount of environmental burden of a product on the basis of prevention of that burden. It is a cost which should be made to reduce the environmental pollution and material depletion in our world to a level which is in line with the carrying capacity of our earth. For example, say if 1000 kg of carbon dioxide is emitted because of the factory that I set up, I would have to invest euros 116 in certain activities which can offset that carbon dioxide. So, this much amount of money is to be invested in say some windmills or setting up solar panels and so on, which will offset the carbon dioxide produced. How does it offset the carbon dioxide produced? So, I am saying that okay, I am not producing energy by using thermal power plants which could have generated so much of pollutants, or I am doing something environmentally good by generating my energy from renewable energy sources. So, for each 1000 kg of carbon dioxide, if for example, we have to invest 116 euros in certain activities which will offset that, not 100% offset that to a level which is in line with the carrying capacity of our earth. People define those lines, those definitions keep on changing. So when this is done, consequently the total carbon dioxide emission in the world will be reduced by 65% compared to the emissions in 2008. So you can see in this particular statement if statement is built. So when I invest that much amount of money, I will be able to reduce the carbon dioxide emissions by 65% compared to the emissions in 2008. As a result, global warming will stabilize. So what I mean is eco cost of 1000 kg of carbon dioxide in this case is 116 euros. So now coming back to the definition again, eco costs are a measure to express amount of environmental burden of a product on the basis of prevention of that burden. So I explained it with an example of carbon dioxide emission, which is regarded as a greenhouse gas which causes global warming. So the eco cost, so carbon dioxide emission is one of the parameters of eco cost. There are many other parameters for the environmental burden like acidification, eutrophication, summer smog, fine dust, ecotoxicity, the amount of use of metals, rare earth, fossil fuels, water and land. So my LCA helps me to identify all the impacts caused on all these different parameters and try to identify what are the eco costs. So currently the problem of manufacturing or manufacturing processes or manufacturers is they quote a price for the product which is based on what is the cost of manufacturing it plus the profits that they would like to add to it. Eco costs, because of the manufacturing process, because of the consumption of the product and all the ecological burdens that it is causing, I need to always do activity. So say for example acidification has happened. Now the government or some agency or the citizens have to spend some money to get rid of that acidification, but that is not getting captured in the product. So eco costs are virtual costs. So in order to understand the real cost of a product, because we are causing ecological damage to it, we need to understand the eco costs. Only then we will be able to, in terms of money, which is more understandable to a large audience of a large variety of our audience, we will be able to understand the ecological burden. So eco costs are right now virtual costs. This is because these costs are yet not integrated in the real life cost of current production chains, which are the life cycle costs. So the eco costs are the hidden obligations, which right now no manufacturer, no consumer is taking a burden of. They are also sometimes called as the external costs. So eco costs are used to compare the sustainability of several product types with the same functionality. Say for example, product A, B and C, all of them. So say in this case we have product example A, B, C and D. So all these products will cause some amount of carbon dioxide emission, some amount of acidification, eutrophication and so on, all the emissions that we listed out in the eco cost. So all of them will release certain amounts of it. Now say product A, my PET bottle is very high on carbon dioxide emission but very low on say eutrophication, or my product B is very high on acidification but it is low on carbon dioxide emission and eutrophication. How do we compare each of them? Because my parameters for eco costs, the ecological burden, so carbon dioxide emission along with acidification, eutrophication, summer smog, fine dust, ecotoxicity, the use of metals, rare earths, fossil fuels, water and land. There are so many different parameters for the environmental burden. How can I compare these two? So there is no other metrics to compare apart from the eco cost, because eco cost tells me okay, matrix 1 versus matrix 2, if we have to nullify the impact on the environment, how much money I have to spend. So that's the importance of the concept of eco cost. It helps me to compare the sustainability of several product types with the same functionality. Even though when we are doing an LCA, we are getting our environmental burden result across many different matrices. I can put the eco cost metrics onto each of them and I can get the monetary value. Then it becomes easier to compare and make a decision. Another terminology which you might have heard quite frequently is the carbon footprint. So, in life cycle assessment, we will be talking about two types of footprints. First is the carbon footprint and the second is the ecological footprint. So, what is the carbon footprint? It is the total emission of carbon dioxide in kgs or kg carbon dioxide equivalent. What equivalent means is, so carbon dioxide is regarded as a greenhouse gas. So, when it is in the atmosphere, it warms up the earth's atmosphere more and more. So, there are many other greenhouse gases, say for example methane, because it becomes very difficult to use. There are lots of molecules which cause greenhouse effect. So, there are a lot of greenhouse gases. So, it is very difficult if we try to measure the footprint of each and every such gas. So, we have converted them into carbon dioxide equivalent and came up with the terminology carbon footprint, which is the total emission of carbon dioxide or carbon dioxide equivalents in terms of kg. So, a carbon footprint is a measure of the impact our activities have on the environment in terms of the amount of greenhouse gases we produce. It is measured in units of carbon dioxide. Now, coming to the next one, which is ecological footprint. So, the ecological footprint is an estimate of the amount of biologically productive land and sea area needed to regenerate, if possible, always if possible, the resources a human population consumes and to absorb and render harmless the corresponding waste given prevailing technology. So, in other words, ecological footprint is the land and sea which is needed to support the life of a person. So, its unit is hectares per person. So, in one of our previous lectures, I spoke about the number of earths that we need to sustain our activities at the rate, to sustain our consumption at the rate at which we are doing right now. It was 1.8 earth. So, in order to do those calculations, what I need to know is the ecological footprint. This is a very so because carbon footprint is little difficult to visualize for ordinary people, and ecological footprint has been a more effective advertisement tool or a more effective tool which is being used by NGOs and other such organizations in order to create awareness amongst people, because hectares per person is an easier to understand metrics for common people. So, I can very easily understand if somebody comes and tells me that the rate of consumption that you are having at this moment will require 1 hectare of land for you, and what the globe can offer you is only say 0.5 hectares. So, I can understand in those terms that I need to reduce my consumption by half. So, a good metrics for common people to understand. So, what we learned from all these discussions is LCA will be a method that we will use to calculate the environmental burden of a product or service. After this module on product design with a life cycle approach, we will go into the product service design module. In that module also, after we have designed products and services, we need to use LCA as a method to quantify the improvements or the downgrades that might have happened as a result of my design intervention. Hence, an LCA is a very important tool. Although LCA does not have an impact on the consumption side, but it gives me numbers in terms of the environmental impact that is being caused as a result of the entire life cycle, including all production phases, consumption phases and end of life. Eco costs are a measure to express the amount of environmental burden of a product on the basis of prevention of that burden. In life cycle in product life cycle design, we can have a life cycle approach, which is from designing a product to designing the entire product life cycle so that I can optimize it, or I can have a functional approach, which is conceptualization from an environmental point of view, that is design and evaluate a product's environmental sustainability beginning from its function. rather than from the physical embodiment of the product itself. So, the reading material for this particular lecture and for the next lecture will be the first one is a website. It talks about eco cost value, it talks about life cycle assessment and gives various examples for the same. You can go through all the content there. And the second one is the paper that I mentioned, which is a LCA measured environmental improvements in Pampers diapers. So, in the next lecture we will talk about how to do life cycle assessment. There are various ways of doing life cycle assessment. So, in this lecture what we are going to work on is something called as fast track life cycle assessment. Thank you.